Wanted to move a little more explicitly into the area of, well, the economic aspects, which are IPRs, patents, and things like that, because it is really critical, I think, in all of this. And just to say, too, in the U.S., we've heard, it just follows up more and illustrates a little more what Vanina was talking about the GM technology, the second generation. There was an announcement only a few months ago that they now have a GM seed that's drought tolerant. And again, to be very specific about this, if in fact it has drought tolerance, that trait it doesn't take GM technology to produce that trait, as you have just, and in fact, some folks are doing, and Ali, you may know this for sure, that the trait in fact is a non-GM trait, but they've inserted it into an existing GM seed that's promoted, and that is in fact not only a false solution, but false marketing, I think we'd say. Do you have anything to follow up as far as second generation? Because if you don't, then we'll move into, I think, this question of social and economic aspects and maybe go into some of the patent issues and IPRs. Like, for example, even if all of this worked, even if GM worked as they advertise, why will that still not be a solution? And we've touched upon this, but maybe explicitly to talk about that from a rural community aspect, economic, national food security, and all of those elements. Do you want to add?
I can just say, I just want to also comment on this issue of genetically engineering crops to, for example, there's this one term that's used, more crop per drop, right? Or climate-ready crops. And as was pointed out before, we have to understand that this is very different than previous GM products out there, which have been mostly qualitative traits, with producing one herbicide or being resistant to a herbicide or producing a toxin against pests. But metabolic functions, such as ones that to tolerate drought or salinity or yielding more, these things are extremely complex functions that include different cascades and feedbacks and intricate and complex networks within the genetic structure of the organism in relation with its environmental changes and conditions and fluxes. So I think that is very important to underline, that these are not kind of like a single gene effect that you can just insert and suddenly a crop is drought tolerant. And even if you do that, there's a huge metabolic cost that is associated with that. So you can have a crop that might be drought tolerant, but then will not yield any food material from its body. And another thing I think that is important to underline is that this is still, these ideas are still within the realm of a predictable biology. So when we think about the climate, and especially a lot of the rhetoric around climate change is extremely based upon these command and control ideas of influencing the climate, geoengineering, and this is very similar to how people have thought about genetically modified organisms. But the climate is very unpredictable, and it's kind of interesting that one of the concerns about climate change is this unpredictable nature of the climate is going to become more and more unpredictable, yet there are these products that are being developed for a predictable kind of climate or soil condition. So what the real solution is actually to have resilient communities with resilient biosystems that are diverse, that can tolerate extreme conditions if they happen to be, not a product that can be immediately shipped to a distant part of the world because there is a drought. What if there isn't a drought? So I think we have to really get out of this way of thinking about ecosystems, whether it's the living organisms or the climate, as something that we can predict and control.
Shall we talk about going forward and, as we say, what if all this really did work somehow, but the aspect of the social, economic aspects of this technology?
I will not take long. I think the concept of market in the traditional community is a place for sharing. It's not a place for competition. So there's no seed ownership there. People, farmers would bring their seed, sometimes the best of their seed, and they share it. So there's no individual ownership of each of the seeds. So if somebody has, people would would look around the farms and they would look at the seeds, the best seeds. And farmers, the owner of that farm, will store that seed. And if somebody wants that seed in exchange for something, they will share it. There's no individual ownership. So that has been the case. That has been the case. And even that travels hundreds of kilometers, it's sharing. But when you introduce the concept of IPR, it's about owning those seeds. It's not about sharing those seeds. So it just doesn't go with the value that communities put on seed. So that's another aspect of GM, the pushing of GM that African farmers find it very, very much difficult to swallow, because it is not anybody's property. It's a communal property. So even if these GM seeds work, I think they will be patented, most of them. So, and that would create a problem. And that would create dependency. Now they are free, what to plant and what not to plant. But this will create dependency. And we don't know what they would, I mean, they may use those seeds as a way of controlling the farmers. So how can we you know, before I say that self-control or participation in decision-making about the life is a most and a very much critical component of climate resilience for the local community. If they give that democratic system, that self-control, to a company, what will be left for them? So that's where we find the whole IPR system a very difficult thing to swallow.
My own personal reading of genetic engineering is that the only reason it was done is it would allow companies to have patenting on seeds and life. And that's why the intellectual property rights treaty, called the Trade-Related Intellectual Property Rights, was even brought into the WTO. And Monsanto's on record saying in drafting this treaty, we were the patient, the diagnostician, and the physician all in one. On the one hand, it takes away the freedom of third world farmers to have their choices, to save their seeds, because when a seed is patented, then saving seed and exchanging seed becomes a crime. And in the industrialized countries, what this has done is after Monsanto's seeds contaminate a crop, the farmer whose seed is contaminated is then treated as a thief of the genetically engineered trait. This has happened with Percy Spicer, the Canadian farmer. It has happened with 1,500 American farmers, and the Center for Food Safety has fought the cases for them. There's a very good report out called Monsanto versus US Farmers, which actually gives the individual cases of how the company threatens farmers. If they find that you have your own seed, they go and threaten you and tell you that they will destroy you by dragging you to court. Monsanto's capacity to destroy governments, regulatory systems, and farmers is huge. The GM debate is not just about genetic engineering. It's not just about a not reliable technology that doesn't breed true. It's about a new dictatorship. Nothing less than a dictatorship will allow genetically engineered crops to spread. So Monsanto must bribe governments to have a dictatorship. And they're trying to use the UN Framework Convention Treaty to sneak Roundup as a climate solution. They're calling it conservation tillage now. You wouldn't even know it's about genetic engineering. And there are enough governments they bribe who are then willing to say, yes, this is a solution. So bribery is the only way Monsanto works. And if we have to have genuine democracy, we have to keep our societies free of GMOs, because it is about our freedom, not just about our safety.